here we go. So say I see something like this. I need my my glasses. Square root of 3, or cube root of x, times the cube root of, or the 6th root of x. Anyone know how to do that? Take your headphone out of your ear, young man. Thank you. I'll show you how to do it. Okay? What you do is you rewrite this in exponential forms. How could I rewrite the cube root of x? X to the what power? The 1/3. How can I rewrite x to the 6th root of x? X to the 1/6. Now when I multiply variables with the same base, what do I do with those exponents? Add them, right? Add them. But the problem is that they have a different common denominator, so I need to find a common denominator. What's the common denominator between 3 and 6? 6. How many 6s is 1/3? 2 6. Okay, that's why he couldn't come to school. That's why 1/3 couldn't come to school. Do you know why 1/3 couldn't come to school? Because he was 2 6. Not bad. Huh? Well, thank you. Okay. I'll be on the Academy Awards next year with my jokes. They invited me. You know. Okay. So anyway, now what do I do with these exponents? Add. What's 2 6 and 1 6? X to the 3 6. What's another way to write x to the 3 6? X to the what? 1/2. And what's another way to write x to the 1/2? Square root of x. Whoa, isn't that crazy? Okay. So what you have to do is first find a common denominator, then you add together the exponents, then if you can, you reduce that exponent, and then it's nice if you rewrite it like this. Okay? That's a hard one. All right. How about division? Okay, so what if I saw, next one, who's that? You okay, Ian?
Yeah.
Good. All right. So what if I saw something like this? 5th root over the 4th root of a. Do it exactly the same way. All right? How can I rewrite this in exponential form? You can tell me that. What goes on the bottom of the fraction? 5 or 2? 5 goes on the bottom of the fraction. What goes on the top of the fraction? 2. So this is the same as 8 to the 2/5. And this is the same as 8 to the what? 1/4, right? So now you got to find it. Oh, you know what? I'm sorry, guys. I wrote down this problem wrong. I'm making it more. Just the numbers are worse. Okay. Change that to a 3 over here, just because the numbers will work better. Okay. So 2/3 and 1/4. What's the common denominator? 12, right? How many twelfths is this? Ian, how many twelfths is it? 8. Very good. 8 to the 8/12. Everyone knows how to get that? You multiply by 4 over 4. How many twelfths is this? 3/12. Okay. What do I do with exponents when I divide? Add them or subtract them. So now I subtract them. So now I get that that's a to the 5/12. And to write this in root form or radical form, 12 goes out here, a goes inside, and 5 goes up there. Okay? Not that horrible, is it? It gets worse. I'm sorry. I'm sorry, Calvin. What did you do this weekend, Calvin?
Missing assignments.
You did missing it?
Did you turn it?
You turned them in. You're the man. Good man. All right. All right. So what if I saw, oh no. What if I saw something like this? New page. See if you could write that as one base to a single power. You guys go ahead and write. Don't put it into radical form. Just go ahead and try it and see what you get. B to the something. B to some fractional power. Give that one a shot. Okay? I'm going to let you. Whoever gets it gets a valuable point. And Jessica's not here. So I'm going to, so I'm assuming what Will did is he rewrote this as B to the 2/3 times B to the 3/5, and then he found a common denominator which is 15, right? And so that's 10/15 B to the 10/15 times B to the 9/15, and then you add together the exponents, you got B to the 19/15. Who else got that? All right, good. Now, the other thing you can do with this is where it gets a little tricky, is you could rewrite this as B to the 15th times B to the 4th, the 15th root of that. And there's a reason I want to do that, because what's the 15th root of B to the 15th? Just plain old B. You understand what I just did? Because B to the 15th times B to the 4th gives you B to the 19th. And it's the 15th root of that, and this is all kind of abstract and stuff. But what that allows me to do is pull out a perfect 15th root outside of the box, keep the 15 out here. That's, the 15 is right here. It's not B to the 15th times B to the 4th. Okay? So that's how you'd rewrite that. So you can pull this B to the 15th outside of the box. You understand what I just did, most of you guys? Okay. All right. Just two more examples, and then I'll be done. Good. So the next thing you have, this is, these ones get really kind of weird. Okay. And I got to tell you, this being my first time teaching advanced algebra 1, and I've taught calculus, and I've taught pre-calculus for years, and I've taught everything. I've never taught this in any other classes, and so whether you will use this stuff in your upper level classes, I doubt it. This stuff. Everything else that we learned up to here, but I've really never used this very much, but it's kind of useful to know. So if you see something like this, okay, this is to the 1/2. First you would rewrite this as x y cubed to the what to the what power? If there's nothing here, what power is it? So there's a 1/2 out here, right? Times x squared y raised to the 1/3 power, right? Or, yeah, that's right. Notice that I can't do anything with these because they're like different, right? If this were x squared y, then I could multiply them together, but they have to be the same, so I can't really do anything with that at that point. So now what I'm going to do is I'm going to find a common denominator with this exponent up here, okay? So find a common denom of the outside exponent. Outside power, I guess I'll call that. What's the common denominator between 1/2 and 1/3? 1/6. So I'm going to rewrite this as xy cubed to the how many sixths? How many sixths? 3/6, right? Because 1/2 is the same as 3/6. Times x squared y to the how many sixths? 2/6, right? 1/3 is 2/6. Okay, now I'm going to distribute through the power, okay? distribute the power. Okay? So what that means, remember when it's a power to a power, you multiply the exponents. Okay? So now I'm going to rewrite this as x to the 3/6, y to the how many sixes? What's 3 times 3, 6? 3 times 3, 6. 3 times 3, 6. 9, 6. You just multiply the top. Okay? Times x to the how many sixes? 4, 6. Okay? Times y to the 2, 6. Okay? Now what I can do, okay? So there's that. I'm almost done. Okay? Now I can actually, since everything is in sixes, yes, I can add the exponents. Okay, so I have x. How many sixes do I have altogether with my x's? 7, 6. Okay, how many do I have altogether with my y's? 11 sixes. Okay, now I'm going to rewrite this. I'm going to put the 6th root out here. I could have just done this in this step, but I have x to the 7th, right? Y to the 11th. Can I pull anything outside of that box? What's the 6th root of x to the 6th? 6th root of x to the 6th. So I'm going to rewrite this as this. X to the 6th times x to the 1. Okay? And I'm going to rewrite this as y to the 6th times y to the what? 5th, because you need to add, like these add up to this. The reason I did that, because now I could pull out an x to the 6th, I could pull out a y to the 6th outside of the root sign, and then I have a 6 over here, and then I have remaining inside the box an x and a y to the, and that's your final answer. Pretty tricky, huh? That's a lot of steps. You think you could remember that? I'm giving you Math Excel to do, so we'll get you that. I'm going to do one more that's real similar to this, except it involves division. Okay? Maybe you guys want to try. I'll let you guys try. Okay, so the next one, basically do the same thing, except you have to divide. Okay? So say I have x, I'll get you started on it. Okay? X squared y cubed, the 4th root of that, over xy, the cube root of that. I'm going to rewrite this as x squared y cubed raised to the what power? 1/4. Okay? Then I'm going to rewrite this as xy to the what? 1/3. I'm just going to finish it off. Okay? Find a common denominator. What's the common denominator between those powers? 12, right? How many 12ths is 1/4? How many 12ths is 1/4? Andy, how many 12ths is 1/4? 4 times what gives you 12? 3. So it's 3 12ths, right? X, y to the how many 12ths? How many 12ths is 1/3? How many 12ths is 1/3? 4 12ths. Okay? Now I'm going to distribute through. Okay? So now I get x to the 6 12ths, y to the 9 12ths, over x to the 4 12ths, y to the 4 12ths. You guys understand that step? What I just did there? Get it? Now what, Tate?
Then you can like go 4 and 6 together.
And what do you get?
2 12s.
2 12ths.
And then you can do 9 and 4, get 5 12s.
5 12ths. okay? And then I'm going to rewrite that as the 12th root of x squared y to the 5th. And there's nothing that could come outside of the box at that point, okay? You're kind of done at that. Okay? That's it. Is that horrible? Not too bad. It's kind of fun, I think. But I'm a weirdo. I like that. So that's it. You guys can